To make sure that Huffman's greedy algorithm is clear, let's go through a slightly larger, more complicated example. So let's work with a 6-character alphabet. Let's call the letters A, B, C, D, E, F. And let's assume that we're given the weights 326 and 826 for these 6 characters. Remember, this problem is well defined even if the weights don't add up to 1. If you prefer working with actual probabilities, feel free to divide these 6 numbers by 27. In the first step of Huffman's greedy algorithm, we find the letters that have the smallest weights, the smallest frequencies. So in this example, that would be the letters B and E. Both of them have weight 2. Now what we do is we merge these 2 letters into a single meta letter, in effect committing right now to having B and E be siblings in the final tree. After this merger, our alphabet is down to 5 symbols, the symbols B and E being replaced by the merged symbol BE, and the weight of BE is the sum of the weights of B and E, namely 4. We can imagine our tree slowly taking shape through these iterations. So after step 1, we know that B and E are going to be siblings, and we know that just A, C, D, and F are going to be leaves. That's all we know thus far. In the next iteration, we again look for the 2 symbols that have the smallest weight. And here the smallest weight symbol is A, it has weight 3, and the runner-up is the merged symbol B sub E. Its combined weight is 4, and that's second overall for these 5 symbols. So in this step, we merge A with BE. Now our alphabet is down to 4 symbols, the merged symbol ABE, which has cumulative weight 7, and then the original symbols C, D, and F, which have their original weights 6, 8, and 6. As far as our tree, we've now committed to the symbol A appearing as an uncle of the siblings B and E, and again C, D, and F, we just know they're leaves somewhere in the final tree. In step 3, we're going to again pick the 2 symbols that have the smallest weights. In this case, the 2 symbols with the smallest weight are C and F, each of weight 6. In our new alphabet, we still have our symbol ABE. It still has weight 7. We still have the symbol D. It still has weight 8. But now we have a new merged symbol CF, and its new weight is 12. As far as our tree, in addition to the information we already knew, we're now committing to having C and F be siblings in the final tree. In step 4, we merge the 2 symbols with the smallest weights. That would be ABE with its weight of 7 and D with its weight of 8. So this leaves us with only 2 symbols, ABDE and CF, and now we know what both of these subtrees of the root of the final tree are going to look like. Now that we're down to 2 symbols, the only thing we can do is fuse these 2 symbols into one, fuse these 2 subtrees into a single one by uniting them under a common root. That gives us the following final output of Huffman's algorithm. What prefix-free code does this tree correspond to? Well, as usual, let's label all of the left branches with 0 and all of the right branches with 1s. And now, as usual, the encoding of a character is just the symbols of 0s and 1s that you see when you traverse a path from the root to that leaf. So, for example, A will be encoded with 0, 0, 0, B with 0, 0, 1, 0, C with 1, 0, D with 0, 1, E with 0, 0, 1, 1, and F with 1, 1.